People keep asking me the same thing over and over. Where is all the innovation actually going? Robotics, AI, supply chain tech, everyone talks about disruption, but very few have seen this system works in real life. So I'm starting a new series with my attempt to answer the questions that have been asked. And feel free to keep asking more questions and bring up things that you want to talk about. I'll try to answer some of these in an honest way. After years working with startups, corporate, government, research labs, universities, and investors across the world, I've seen what worked, what failed, and what's coming next. And right now we are entering a decade where the biggest shift won't come from the hype. It never came from the hype. They come from details that most people ignore. I'm looking to talk more about innovation in logistics, specifically in robotic, AI, what works, what doesn't work, and we'll drive some focus into a specific problem. We all know that there are many problems in supply chain in regards to innovation. First of all, there is the labor shortage. Volatility keep going up and down. Sustainability demand is all over the place. Speed expectations. Now more than ever, people want whatever they order in same day, next day at their home. That's especially in e-commerce, but also in the stores. You don't want to come and order stuff and you don't have that in stores. Technology readiness. What are we talking here? Autonomy, maturing. AI moving from prediction to decision. Robotic reaching consistent thresholds, which is not the case until recently. Adoptions. Economics. Is there any economics for the adoption? Sometimes we see solutions and problems that are being solved that doesn't really bring any value to the company that's utilizing those. No return on investment in many cases. Infrastructure constraints. Culture resistance. We see that often. And of course, regulatory frictions that's coming. Most conversation only talk about the first two, about problem pressure and technology readiness. I really want to focus on the adoption in reality, the third problem that we talked about, where things actually break or become real. Let me start with two stories. One, a successful proof of concept that became actual deployment, and the other, a miserable failure. I'll start with the failure. There are multiple things I tried in the past to deploy in warehousing and the transportation section of supply chain. What we saw a lot of the time is that robotics are out there, but not there yet fully. That either requires a lot of fence guarding around them because they're not collaborative robots and require some kind of guards and blocking areas, etc. Other problems that I saw in the past was actually productivity. There's a promise of certain productivities. We will be able to move X amount of cartons, X amount of containers, X amount of pieces per hour. In reality, you reach way lower productivity than promised. That is very problematic when you come and you try to convince organization to actually go and deploy robotics in a big scale, especially when it requires for you to change your current existing locations. Brownfield, as we call them, the current locations, requires a lot of details on how you can deploy something new into them. Of course, a greenfield, when you have a new location, that's much easier. You can deploy things and things are easier. But one of the solutions that we actually looked into was autonomous forklift in a warehouse. What we very soon came to realize is that every different forklift providers out there is actually giving you one small portion of the actual work of a forklift driver. Companies can help you with loading and unloading from a container or trailer, but they cannot do anything else. Another company can help you with A to B. Another company can help you put it on the shelf up to certain height. Another company can put it on the shelf only above certain height. You really now suddenly requires to have 3 or 4 different providers of the technology to do something that has been done before by one person, one forklift. Now, you could argue and say, what do you care? It's still better productivity because you can divide the work into 4 different segments, which is right if you have a 24/7 type of work. But if you are not the top tier 5 largest companies in the world and you don't have 24/7 type of operation, and suddenly you have the forklift sitting idle and not doing any work for a few hours, now your calculation of return on investment become much worse. And suddenly it shows, instead of 24 hours or even 18 hours or 20 hours a day, suddenly you're starting to show, oh, it's only 6 hours, 8 hours, 12 hours, and it's become much tougher to actually justify this technology. So a lot of those elements needs to be considered way in advance, and definitely we'll discuss more use cases in the future. A very interesting solution that actually works very well, it's a digital twin. In one of my previous use cases, we decided to deploy a digital twin to help the dredge operation from the port. Dredge is the movements of truck from port into the first warehouse. So we looked into how can we improve the work that has been done in the current dispatch team. Now, the dispatch team used to go and look into 13, 14 different systems, grab information, digest it, analyze it, and then make some decision on how to dispatch the team. It was quite an extensive amount of work to go and do this type of digging into all the different systems to understand what's booking do we have, what's availability do we have from the customers, where the truck, where the chassis, where the containers. Then, of course, it led to forgetting chassis and containers in certain location, making us responsible for detention and demurrage, or the customers pay for that, or us, which didn't make a lot of sense. What we decided to do, instead of taking a huge, big project of digital twin and take 5 years now to deploy that, we actually broke it down into 3 segments. Each of them had an ROI, had some improvement, and could allow us to know, are we on track here or do we need to actually move forward? So divided it into 3 stages. The first was actually visibility, taking all these 13, 14 systems into one, bringing it on the map, having aging, and understand really, hey, what is happening in each of those segments, all in one place, making the work of the team much, much faster. ROI came very, very fast with that. Stage 1. Stage 2 was, now that I have all the information in one system, how do we actually use it to create much better dispatching algorithm than any person could ever do? People are smart, they know what they do day in, day out, but there's a lot of limitation to the human being, the amount of information they can handle and take into consideration. The system took all the data, digested it with, of course, multiple different limitations that we put in advance, what you can, what you can't, what should be considered, and helped us to improve the turnaround of the trucks that going back and forward from the port by close to 50%. That was amazing improvement in utilization of the trucks and the drivers, and helped to reduce dramatically the detention and demurrage. Stage 3 is actually, now that we have all this type of information in one system, now let's run simulation and what-if scenarios. So you have a new customer, all the data that you're running on the day-to-day sits in there. You want to actually understand, is it worth for me to take this business? And if yes, what cost, what other limitation I should think of? Plug this new data into the current data systems and come up with ROI scenarios, figure out how to run it, what is the cost, what is the best cost to run it, do I need to increase my drivers, my truckers, do I need to increase the area that I'm running into, actually decrease that. So that was a very, very interesting success stories that I can talk about. Definitely there are many more, but wanted to kind of make sure that I'm giving some examples of things that goes well and things that doesn't. Another point I wanted to talk about is the fear of AI. A lot of the time we see people afraid that AI will replace them, the operators, we won't have the right knowledge anymore. I argue that, of course, there will be certain jobs that will be too easy for AI to replace, but the judgment of the person is important. Operators that use AI will replace operators that do not use AI. That capabilities to be able to mingle and collaborate and adopt to the new type of solutions will be much more interesting for companies and for solutions to be deployed much faster. So what's coming? I'm looking to talk about different robotics and ROI around that. Definitely AI beyond prediction. Until now, AI was mainly used for prediction. Now we see a little bit of LLM type of AI. How do we use that to handle large size of data? But I think there is definitely more than that, especially with agentic AI. How to unload the bottleneck? What will be the hidden economies of the deep tech? And how investor should rethink hardware? Please bring more of your questions. If you have any topics you would like to explore, I will be happy to talk and share some of my experience. It is coming from different angles of supply chain, handling air freight, ocean freight, supply chain management, warehousing, distribution, etc., and all related to some technology. Just to close things, I just want to challenge to all of you. What is the one assumptions you have about robotics, AI, or supply chain tech that you are willing to question this year? Thank you very much, everybody. Happy to be here and share my knowledge. Keep bringing the questions. We'll be happy to see more and share that in my next sessions.